All right, so I asked you to do the box method to factor this. So anytime you have four terms, it's really the first thing you should look to see if it works. We talked about it the other day, and we said sometimes it just doesn't work. So if I look at the GCF go in this direction, it's x squared. If I look at the GCF go in this direction, it's what, -2? If I look at the GCF going this way, it's x. So the first one works, but does this one work? No. So you can't factor this using the box method. It just doesn't work. And that happens sometimes. Sometimes things don't factor out using the box method. That's why it's just something you try to do. And if it works, great. If it doesn't work, well, we've got to have a different way to do it to see if, in fact, it does factor. So since it didn't factor that way, we've got four terms. We can't use the x method. Is there a different way that maybe we could factor this? We've been factoring it, but when we did these last week, if we didn't use the back box method, we said you were given one of the zeros. Okay, well, we're not given the zero this time. So is there a way we could figure out what one of the zeros could possibly be? Go ahead.
Wouldn't one of the zeros just be -5? Because would you just kind of do like half the box method? Because wouldn't it be like 5?
I mean, if you did partially, so you could try it. So guys, ladies, unless it's math related, don't be doing it. This class is getting absolutely terrible about this. It's almost every single day I have to stop and tell you to be quiet. It's getting old. Again, I don't mind if you're sitting there talking about math. Great, perfect, but you're not. So at that point, it just becomes rude. Okay, so could you do partial box method to see if, well, does -5 work as one of the factors? Yeah, you could try that.
Positive.
Right, so it would be +5 there if we did this. So we could try -5 inside of the box to see if -5 worked inside of the box. We could try that. But are there other numbers that we could use as well besides 5 or -5? Because there are. 2 be work. Could 2 be used? 2 could be used. What else? What else? So if I were to set this up, we have to have x plus something, right? And then if we have x plus something, that gives us x squared plus something x plus something. Okay, it has to be kind of in this form. And obviously the question marks aren't all the same thing. But what do we know about the last two, this question mark here and this question mark here? What do they have to be? They have to multiply together to be -10. So if I can list the factors of 10 or -10, those could be the possible zeros. So my factors of 10 are positive and -1, positive and -2, positive and -5, and positive and -10. Those are all of the factors of 10. So all of these have the possibility of being one of the zeros. Okay, but let's try -5 and see if it works. If we try -5, we've got a 1, 5, -48, and -10. So we drop down the 1, that gives us -5, that gives us 0. I did it. Is it good so far? Am I good so far? That gives us 0, that gives us -48. Is that going to work? No. So -5 isn't going to work because what does my remainder need to be? 0. And it's not 0. So I know now that negative 5 is not going to work. So now I say, instead of trying negative 5, I say, okay, well, let's try 5 instead. Bring down a 1, 5, 10, 50, 2, 10, 0. So positive 5 worked. Okay, so my factor is going to be x minus 5. That's one of the factors. That's probably why I put x minus 5 up there when I did it earlier. Okay, so x minus 5 is one of the factors. I know it has to possibly be one of those, but if we get that remainder of 0, then my other factor of this is x squared plus 10x plus 2. Okay, so now I've got it in a factored form. We need to check to make sure the x squared plus 10x plus 2 can't be factored any further, and it can't. We don't have two numbers that when multiplied together are going to be 2 and add up to be 10. So this is actually the factored form of x cubed plus 5x squared minus 48x minus 10. And if we're just asked to factor it, that's what we need to do. Now, if negative 5 didn't work, then we'd have to try 2. We'd have to try 10. Is there a way to eliminate them? It really becomes a guessing and checking and trying to figure out which ones work. Can you eliminate 10 probably right away? Yeah, you could probably eliminate 10 right away because you can get numbers that are so big that it's just not going to work. But that's really the only one in this case that you could eliminate. And we're not going to talk about, did this a lot last hour too. We're not going to talk about completely how we figure out how they go away. That will leave that kind of to the algebra, to your pre-calc teacher. We're kind of use a guess and check method to try to figure these out as we graph them. Okay, so factoring is going to be the first thing that we do today. So let's look at another example. Oh, well, let's do this first. This has a theorem. We should probably give you the theorem. Theorem itself is what we call the rational root theorem. Okay. A rational root theorem says this: a rational root of a polynomial function. Let me get rid of this Q for a second. You don't need that Q right now. You don't need that P right now. So we have f of x, a to the n, x to the n, plus, then just put a to the 0. All of this inside of here is just more stuff. This a to the n is your first term, and this a to the o is your second term. Now, we've got two things within this that we have to concentrate on. It's P and Q. P is going to be the factors of the last term, A of O. And that's why I seen the P up there earlier that I erased. The P is kind of right there, kind of. Because it's not that value itself, it's the factors of that term. So before that P value was 10, that value was 10, so the P values were 1, 2, 5, and 10. It's the factors of that. The A of n is your Q value-ish. Okay, so Q is the factors of the first term. Today, our first term is just going to be 1. So we're not going to have to worry too much about the Q2 term. Tomorrow, it's not going to be. It might be 1, 2, or 4. Okay. The rational root theorem says that if we take P and divide it by Q, one of those could possibly be one of your factors, essentially. Will they be? Meh. Probably today, yeah. Do they have to be? No. But the chances are pretty good that one of them is going to work, especially with what we're doing with this. So it's that P over Q value. It's the factor of the last term over the factor of the first term. So now if we go ahead and look at the next one, example, I've got x cubed minus x squared minus 6x plus 8 is equal to 0. Okay, so now this time it equals 0, so we're not only going to factor this, but we're also going to find its zeros. Okay, so first if we want to look at all the possible roots. So our possible roots are going to be P over Q. Our factors of our Q is just 1, so the factors of 8 are positive and negative 1, positive and negative 2, positive and negative 4, and positive and negative 8. So if we go P over Q, it's just going to be the factors of P in this case because our Q values are just 1. Okay? So now we just start trying them. Okay, we pick one and we go with it. We're going to try negative 2 and see if negative 2 works. This is why synthetic division is something that we want to be able to do. And we want to be able to do pretty quickly. Does negative 2 work? If I did it right, negative 2 times 1 is negative 2. That gives me negative 3. That gives me 6. That gives me 0. Does it work? Nope, doesn't work. So I just erase it. That's why we use pencils in mathematics. And we just try 2 and see if 2 works. And these are our zeros. So we've got 1, we've got 2, we've got 1, we've got 2, we've got negative 4, we've got negative 8, we've got 0. It works. So 2 is one of the zeros. So since 2 is one of the zeros, my factor is going to be x plus 2 or x minus 2? X minus 2. So our inside the box is the opposite of what we see. And then we've got x squared plus x minus 4. And this is still going to equal 0 because we want to find the zeros to this. X minus 2 obviously can't be factored. X squared plus x minus 4. Is there anything that multiplies to be 4 that has a difference of 1? Nope, so it doesn't factor. Okay, so if we have to find the zeros, the first 0 is pretty easy to find. First 0 is just 2. And we've already said that. But now for this part, we have to use the quadratic formula. Or you can complete the square. I wouldn't advise it because you'd be dealing with fractions. So we use the quadratic formula. So x is equal to the opposite of b, so negative 1, plus or minus the square root of b squared, which is 1, minus 4 times negative 4, so plus 16. Does that look right? 1 squared minus 4 times 1 times negative 4, yeah. All divided by 2 over 1. So that's negative 1 plus or minus the square root of 17 over 2. And those are our other zeros. And we're done if that's all they're asked to do. They just ask you to find the zeros, you're done. But it becomes a process, a little bit more of a process now where you're not going to just always be given what that 0 is. You're going to have to use a little bit of trial and error to figure out what that 0 is. Okay? Questions with that one? Let's have more fun. Let's look at this one. So now we don't have 4 terms, so we're not going to use the box method. The box method, might work, but it might not work. Box method ain't going to work if we've got 5 terms. So what are my possibilities? What are my factors of p? Plus and minus 1, plus and minus 24, 1 times 24, plus and minus 2, plus and minus 12, plus and minus 3, plus and minus 8, plus and minus 4, plus and minus 6. So there's all of our possibilities. So you guys, you've got 1 and negative 1. You've got 2 and negative 2. You've got 3 and negative 3. You've got 4 and negative 4. So you guys got 1, 2, 3, and 4. Save us some time. Okay, so did 1 work? Did negative 1 work?
No.
Negative 2 work? So then did 3 or 4 work? Nope, negative 3, negative 4. So inside the box is negative 2 or the factor is?
Inside the box is negative 2.
Okay, so inside the box we're going to use negative 2. So again, we'll just confirm their math. Plus I need to write it down anyway. So we've got 1, we've got negative 2, we've got 0, we've got 0, we've got 1, we've got negative 2, we've got 0, we've got 0, we've got negative 12, we've got 24, and we've got 0. Perfect. So our first factor is x plus 2. Our second factor, x to the 4th plus x squared minus 12. Okay, it says equals 0, so that means we're going to find the zeros or the roots. X plus 2, that's taken care of already. X squared, x to the 4th plus x squared minus 12. I think that factors, doesn't it?
Yeah.
If we use the x method, negative 12 and 1. So 4 and negative 3. So it's x plus 2, but now it's going to be x squared plus 4 times x squared minus 3. Can any of those be factored any further? Can that one be factored any further? It has to be negative. Okay, that's the sum of squares. Sum of squares doesn't work. Has to be difference of squares. Okay, so none of them can be factored, so we're good to go. So what makes this first one 0? Negative 2. What makes this 0? I, 2i, plus or minus 2i? Plus or minus 2i? Subtract 4 from both sides, take the square root. Square root of negative 4 is 2i, so plus or minus 2i. And then plus or minus radical 3. Okay? So those are your zeros. These are your real zeros. Okay, so your real zeros are where they cross the x-axis. We cross the x-axis at negative 2 and plus radical 3 minus radical 3. And then we've got our imaginary 2i. So that's going to put a little bump in our graph at some point in time. Questions with that one? Oh, a really good one. So we got x to the 6th plus 4x to the 4th minus 41x squared plus 36. So our possible real zeros, plus and minus 1, plus and minus 36, plus and minus 2, plus minus 18, plus minus 3, plus minus 12, plus minus 4, plus minus 9, plus minus 6. Now just start thinking about this being like a 4. Then we'd have to divide each of these by 2 and each of those by 4. We'll do that tomorrow.
What?
We'll do that tomorrow. You have 1 positive and negative. You have 2 positive and negative. You have 3 positive and negative, and you have 4 positive and negative. And then when you find one, just stop. Don't go any further. You'll see why in a second. Please make sure that the group 2, one's doing positive 2 and one's doing negative 2. Don't everybody just do 1 and stop. Make sure both 2 and negative 2 get done.
Oh, I got negative 109.
Anybody do negative 2? You guys did. And you guys did. Right? Okay, so now what we have going on, and you have to be careful with these. Obviously, you've got to watch your math when you're doing these. That becomes the biggest hang up sometimes when doing these. You can eliminate, this column can get eliminated pretty quickly. I mean, you start getting blown up, huge numbers, just eliminate them right. And that's why I kind of just started with the 1, 2, 3, and 4. So, a bunch of different ones happened, and a bunch of different ones worked in here. Okay, so I think the ones that worked were negative 1. Was it negative 1 or positive 1? So positive 1 worked, negative 2 worked, and 2 worked. Okay, so all of them worked. So technically speaking, x minus 1, x plus 2, and x minus 2, those are factors. All three of them are factors. However, there's stuff left because this is only x cubed. So how are we going to find the rest of it? Well, yeah, you leave it like this, you're not. So what you have to do, and you can pick any one of these. It does not matter which one of these you pick. Or, yeah, it doesn't matter which one you pick. So if I pick negative 2 or 2, I'm going to put 2 inside my box. So we have 1, 0, 4, 0, 0, negative 41, 0, and 36. 6, 5, 4, 3, 2, 1. I got too many 1. I got an extra 0 right here, right? Right? That's why I always count. Do you notice me counting 5, 4, 3, 2, 1? That's why I do that. So I draw this line. So I've got my 1, I've got my 2, I've got my 2, I've got my 4, I've got my 8, I've got my 16. Am I right so far? 16, 32, negative 9. Where did we do wrong? Does positive 2 work?
Yeah.
Do they both work? Did I mess up my math somewhere? This is negative 9. Oh, I just didn't go far enough, did I? So 36 and 0. Okay, so it works. So now we're left with x to the, so we've got x minus 2 times x to the 5th plus 2x to the 4th plus 8x cubed plus 16x squared minus 9x minus 18. All right, so now we're left with this mess, right? Now, I used x plus 2 as my one of them to done. I've used that one already. Now I got to do it again. Hey, because we still don't know how to factor this part of it. So we don't know how to factor, but we know x minus 1 and x minus 2 are the factors. So now I'm going to put a 1 in there. And now I'm just going to use what's left now. So I'm just using what's left now.
You did use the x minus 2, not x plus 2.
Right. I used x minus 2 as my factor, right? But I used 2 as my 0. Yeah. I use 2 as my 0 here. So that factor is, oh, I crossed out the wrong one up top. Yeah, I crossed the wrong one out up top. Okay, so now if we do this one, if we use 1, I've got 1, I've got 1, I've got 3. I've got 3. This is going bad. Got 11. I've got 17. Got 7. Am I right so far?
Why is that a 16? I thought it was a 16. It's 16. Above the 11, it's a 16.
No, it's a 16. 27. Good catch. 27. Erase. This is why this stuff is great. 18 and 0. So we got the 0 again. So now we've got x minus 2. We've got x minus 1. But we're still sitting there with now x to the 4th plus 3x plus 3x to the 3rd plus 11x squared plus 27x plus 18. This is great. So now we're going to use negative 2. Since we used positive 2, we used 1. Now we're going to use negative 2. 1, 3, 11, 27, and 18. 4, 3, 2, 1, none. That's 1. That's negative 2. That's 1. That's negative 2. That's 9. That's negative 18. That's 18. That's not 18. That's 9. That's negative 18. And that's 0. Are you having fun yet? So x minus 2, x minus 1, x plus 2, x to the, what are we at now? 3rd, plus x squared plus 9x plus 9. I've got 4 terms now. So I've got 4 terms, so I'm going to try the box method now. Since we're down to 4 terms, let's try the box method. X cubed, x squared, 9x, and 9.
If the box method works, but also the synthetic division work.
Yeah. Yep. Yep. So that's x squared. That's 9. That's x. And that's 1. Yep. It works. That works, right? Holy cow. So the factors of this, x minus 2 times x minus 1 times x plus 2 times x plus 1 times x squared plus 9. Probably would have worked earlier, but didn't. They could have used -1 up top. Now, set all them equal to 0, then you have all the zeros. But you can see how big of a pain this can be. Right now, if I would have started this with -2 instead of 2, if I would have made this -2 instead of 2, it's still all going to work. You're still all going to get to the same end result. It's just a different way of getting to it. Okay? More than likely what's going to happen, you're going to find one that works. And then you're going to do that one, and then you're going to see the next one. And then, since we didn't change this, we kept this, well, this became 18 now. We could just use the factors of 18 to do it. We could just use the factors of whatever to continue to do these. So, they take some time. They take a little bit of work. You can expect one like that on your test. Probably won't be to the 6th. But it'll probably be to the 5th. We'll take one step away. Okay?
So like they also do.
Tomorrow we're doing day 4 of this. Tomorrow the A value is going to be, there's going to be an A value out here. Or a Q value. 1, 2, or 4. Or 1, 2, or 6. 24 and 36 are brutal. That would be like bad. But we'll try it tomorrow. Review day Wednesday. Your assessment will be on Thursday for sure. Friday, we've got a lot to cover on Friday because I'm gone all next week. So we've got a lot of assignments to cover in one day.
What if they say no?
I'm going to Orlando for a week.
Okay. So what? He is good.
I have to work. I'm working. I'm going to a track clinic for the week in Orlando.
Do you like track? So you'll be having.
Wait, are you the trap coach?
Well, it's a track and cross country. But I'm going there. I do a whole bunch of things.
How many years have you been doing cross country?
This is year 28.
Oh, you probably have.
Been here a long time.